Section 2.7, combining functions. So we can combine functions to form new function. And how can we combine? We can add them, subtract them, multiply them, or divide them. So if you add, so you will get a new function. Usually f plus g is, we can call it h if you want, and f minus g, f times g, and f divided by g. So remember, when we have h of x is equal to f of x plus g of x, so this is a sum, and f of x minus gx is a difference, and fx times g of x is a product, f of x divided by g of x is a quotient. But with the quotient we have another condition here, that the denominator should not be 0. So if any value that makes the denominator 0, we have to take it out of the domain. Now how do we find the domain of these functions? The domain of the first three, the sum, the difference, and the product, is basically the intersection of the domain of f and g. Okay? And how do we find the domain of f divided by g or the quotient? So we already have the intersection. So from the intersection, we also throw away any x value that makes the g of x is equal to 0. So let us look at these examples. So we are going to find these functions and then their domain, and then we also would like to find this thing, these values. Okay, the first example I'm taking here is f of x is 4 divided by x minus 3, and g of x is x divided by x plus 4. So f of x plus g of x will be, I'm just writing f of x plus g of x. So this is f of x. You should be able to see that this is g of x. And now I have to combine them and simplify them. So that's what I did. Common denominator, simplify, eventually. So I look here, I am keeping this as in factored form, keeping this in factored form, because I want to see if my numerator will be factored or not. So once we see that what our numerator is, and if it cannot be factored, now we can actually do the multiply the denominator. Become x squared plus x minus 12. Okay, so now I'm finding the value f plus g, as we said in the part 2 of this, at 4. So plug in this function that we just found, this one, and I get 9 over 2. Now note here, on the side I also did f of 4 plus g of 4, because that's what I wanted to show you, that f plus g of 4 is the same thing as f of 4 plus g of 4. So we get the same answer. What is the domain? As said above, so it is the intersection of the domain, means the domains which is common to both f and g. So here I have the domain in this number line, the blue one. The purple one is the domain of g, and the green one is the domain of f. So, or is it otherwise? Yeah, green is the domain of f, and purple is the domain of g. And when we see that in this case, so we have to throw away -4 and we have to throw away the 3. So that gives us the domain here. -infinity to -4 union -4 to 3 union 3 to infinity. Is the domain. So in the same way I find f of x minus g of x, so same functions, take them, multiply, take the common denominator, simplify, and we end up with this result. And now for the domain, same thing, domain will be the same as above. And then I found the f minus g of 4, which is coming out to be 7/2. If you want to check, you may check f of 4 minus g of 4. So check that, it should come out to be 7/2. Okay, f of x times g of x, so you multiply them. So remember how we multiply fractions, to top with top, bottom with bottom. So I get that, and when I simplify, I end up getting this. Domain is same as above, and f times g of 4 is coming out to be 2. Again, check the other thing, what is f of 4 times g of 4. The fourth thing is the quotient, so f of x over g of x. So here I have f of x in the top, g of x at the bottom. And remember, we should not have the 0 for g of x at the bottom. So we set g of x is equal to 0, which will give us x is equal to 0. So g of x will be 0 when x is 0. So 0 should not be in our domain of the f of g, f over g. And so here I'm taking the intersection which we already have found, and I'm adding another point which is whole, or which is thrown away. We end up with this new domain, and then the checking with the number. Now I did the other example, which is with the square root. Now the only thing I wanted to show you here, that when we do addition, we cannot simplify, because we cannot go further, so we leave it as it is. And similarly, subtraction, multiplication, you can do a little bit more work here. So that's what I'm getting after multiplying the expressions. And domain of f plus g and g, f times g and f minus g will all be the same. And how am I getting the domain? By doing this thing over here. So I have the line, I have -4, -2, and 4, because domain of f, by the way, is here. I calculated it. Remember, it's a quadratic inequality. So I'm going to use the sign chart. So I see that the domain is -4 to 4, including -4 and 4. So here we have the purple one is showing the domain of f, and the green is the domain of g. So when we overlap them, the common portion is from -2 to 4. So that is the domain for each of these three functions. What about f over g? Well, when we do f over g, so we cannot have this quantity to be as 0. So if you set it equal to 0, basically what it means is that you cannot have x is equal to -2. So now the domain looks similar to the previous, except that the only difference is that now we have a parentheses over here, not a square bracket. That's the difference from the other. This is how we find if we find the functions f plus g, f minus g, f times g, and f over g, and this is how we look at the domains. So the next thing is composition of functions. We will talk about that in another video.